This is Engineer-in-Chief Val Prest setting up for our Pennies test today to determine the coefficient of friction of pennies. This is a world premiere.
Pull the whole plywood out some, but we're going to take it off anyway. Well,
we're getting ready to begin our experiment, and we're staging some buckets, manageable weight, with the help of this nice little cart, and we're going to fill this marvelous container that Val has built. And this is our half a cubic foot box, our pulley setup. Alright, first bucket's coming.
Nail, and we'll try to take measurements this way, and at the 45s, and we'll average the horizontal distance out to the edges of the pennies.
Okay,
and that'll give us
the angle of repose.
That'll give us the distance from here out to here.
All right.
And that then gives us this. It gives us this, which is the vertical, gives us the H, and then we can get the angle.
Okay. Sounds like trigonometry to me.
That's what it is. The pile is measure from the bottom of this to the top of that diamond.
Yeah, we have a diamond.
There.
Just pretend you're a surgeon.
You'll have to pardon my fingers. They're arthritic. When I point out in space, it's a curved line.
You have to take the cosine of the...
I know it sounds weird that it's so exact, but it's pretty much 7.5.
7.5, what it is. So one of you is going to have to measure horizontally from the nail. And we're going to do it on an average basis here. Come on, Bob. Okay, there's one measurement. Take it to this edge of the stick, the outer edge, where the string is. That's 14. Stop moving there, Bob.
14.
Okay.
Those are good numbers.
I can't reach that far.
And so do we want the bob to... Is that about
Come
good?
on, hand, stop shaking. That's good enough. Half-ish.
13 3/4.
Okay. Now we'll go to the other side.
So we're filling buckets and transporting them across the yard to our experimental platform. Terry Moisson helping out here. So here we are filling the experimental box.
We'll see what we need for the penny block first. Let me see if that's move up. That was him.
Yeah. Just look at it and read that. Mr. Siren, read that.
Yeah, Mr. Siren definitely should be done.
So we're almost reached the experimental height that we need.
Yeah,
And
let me check it once more.
Val Prest is a penny mason. He's not going to smooth it out.
With just little squares there. How would you, oh, I guess so we'll see.
There,
We put that frame on the,
Very good.
so,
Very good.
so on the pennies, and we fill it with pennies.
This is kind of what Uncle Scrooge McDuck did. He played with his
And
money.
then we fill the bucket down there with different amounts of pennies, and we can see how much force it takes to break the coefficient. Yeah.
The less the force, the higher the lateral force on the walls of the tank.
He knows the rest.
Now the big test to see if we got it at the right height.
Yeah. What we didn't do first time, which is mine. You're like, yeah, that should be. Well, they told us it would work. Oh, it holds.
Oh, that looks pretty good, Val. Do we want to just pop the level on that? Or do you think it has to come up a little bit more?
No, we're good as far as top of. I just want to get the level. One theta, when we go in to look at what the, we've got to get what's called the coefficient of pressure. And that's equal to the square of the tangent of 45 degrees minus that theta angle divided by 2. Thinking in terms of liquid, water, theta equals what in water?
It says
You can't measure it, right?
so yeah, it'd be so it'd be 90,
No,
10 of
the
0.
opposite. Be 0.
0, okay.
It's a flat surface. In other words,
Right.
this would come right down level with the surface, and so this angle theta wouldn't exist.
Yes.
So that would be 0.
Right.
When it is 0, this term disappears. So you're looking at k being the tangent of 45 squared. Tangent of 45 degrees. Do you know what that is? 1. Yes, it's 1. And 1 squared is what?
1.
1.
Right.
Okay. So what happens is that you take that 1 times the vertical weight of water, or pennies, 62.4 for water. That's the reason why at the bottom of a foot of water, the pressure is the same in all directions.
Ah.
And it falls right out of this equation. So that coefficient is 1.
Wow.
Now, if you get a high angle theta, let's say you get up 30 degrees, and you take half of it, that's 15 degrees. You deduct it from 45 degrees, that gives you an angle of 30 degrees. You find the tangent and square it, and now k sub a gets less than 1.
Okay.
And as the further away it is going down to 0, the less the horizontal force is against the side of the tank. And what we're seeing already is that this is slippery.
Yeah.
And the angle of repose
Shallow.
was down, what, 18
18.
degrees? 18 and a half degrees?
Makes a lot of
This
sense.
could be similar to it, or maybe a little more. I'm expecting it to be a little bit more. But what happens is it's getting closer to the 1. So the weight of pennies, which on that other sheet you weighed up, do you remember what it was for the 6 inches? And
Oh, you mean for half a cubic foot?
yeah.
Well, with the tear, it was 117, so probably about 110 pounds for half a cubic foot, so 220 pounds.
So 220 pounds. And if it was 0, angle theta was 0, then the force against the side of the tank would be like 220
Wow.
pounds
Yeah.
That's
a
amazing.
square foot. That's the reason why I've been saying
Yeah.
all along it was blowing the walls out.
Yeah,
That
wow.
makes sense.
I wanted
That's
you to
a lot.
understand this.
Yeah,
Now I
interesting.
That's awesome.
So that's the reason for the test.
This is so
Right.
exciting.
All right.
So now we need to go get more pennies to load into
Just
the
for the
box.
box. I mean, box.